Okay, so solving a quadratic is something that you're going to do forever now in math. Okay, it's going to be like basic as you go progress into pre-cal and calc. You're just going to be assuming that we know how to solve a quadratic. Okay, one way to solve a quadratic, we're going to learn a bunch of different ways. Today we're learning how to factor. I think factoring is one of the easier ones if you can, but you can't always factor, unfortunately. So students will solve a quadratic function by factoring and know the different names of the solutions to a quadratic function. So the first thing we need to deal with is systems of equations. Okay, a system of equations is a set of two or more equations using the same variable. Write it down, please. You guys have solved systems of equations for linear equations. Now we're also going to do that with quadratic equations. Okay, the solutions to a system of equations is an ordered pair that satisfies all equations in the system. So it's true for both equations. Sometimes system of equations can have no solutions. Sometimes they can be the exact same thing, so it means all of the answers, all of the real numbers will work. For this, we're probably only going to have one or two answers for our systems with parabolas and quadratics. And if you graph it, the point at which the two graphs intersect, that is the solution. Okay, we got that all written down? Okay. So we're going to solve this. We're going to solve by graphing here. So here's my equation. I have negative x plus 3 squared equals negative 4. Okay. So I want to know when this parabola will equal negative 4. Okay. So one way we can do that is by graphing it. I can graph the left side. Oopsie. I can graph the left side, which is the negative x plus 3 squared, and then h of x equals negative 4. Let's graph this, because I kind of know how to graph this already. We want to know our vertex. Oh, good. Negative 3, 0. Remember, inside the parentheses, you change the signs. So we go where x is negative 3 and y is 0, which is right there. Then we need our a value. Negative 1, good. So then we graph a over 1, then 3a over 1, then 5a over 1. So we're going to go to the right one and down 1. And then to the left one and down 1, because it's negative 1. Then to the right one and down 3, 1, 2, 3. Left one down 1, 2, 3. Then we're going to go, Why am I touching negative 4?
I said, didn't it already? Because I'm supposed to make it.
Oh, we'll get there in a second, but good. Yes. Then we're going to go down to the right one and down 5. 1, 2, 3, 4, 5. We're not going to quite get there, but we can get an idea. Maybe a little further. So this is our parabola. Any questions over that? We're good? Okay, so that is the right side. Now we want to know where h of x equals negative 4. Okay. That is going to be a horizontal line. through -4 on the y-axis. Okay, if you remember when you graph linear equations in Math 1, this is like y equals -4, so it has to show where y is -4, not x. So we're just going to come down here. Hold on one second. Okay, so we're going to graph that horizontal line through -4 on the y-axis, which is right, not there, but I hope I can move it down to where it is. No, it doesn't want to move that. Okay, so draw a horizontal line through -4 on the y-axis. Okay, we just want to find where those two graphs intersect. So Anthony said he saw it right here. So one of the intersections is at -1 for x and -4 for y. There's also another one, and it's at -5 and -4. Hold on. Okay, so that's how you can find the solution. Okay, graph the two sides and see where they intersect. Any questions? Yep. Okay, and in this case, we only really care about the x values because I already know what the y value is going to be. So truly your answers would just be the x values. So you'd have x equals -1 and -5.
Yeah. Or A.
Any questions over that? Okay, so the next one. Okay, this one's a little bit more difficult to graph. The x squared plus 4x minus 5 equals 6. Okay, we're still going to do the same type of thing. We're going to have f of x equals, we're going to use a graphing calculator, plus 4x minus 5. You do. I will show you. And then h of x equals 6. Okay. So you guys have internet and wonderful smartphones. Okay, then you should have some sort of access to this. You're going to go to desmos.com. We've kind of done this already. Nope. Not what I want. There's an app for your phone if you want to download it to your phone. You can also use this. Okay. Not right now, because we don't need that right now. But here's what we're going to do. We're going to graph it. I'm going to type in x squared plus 4x minus 5. Oopsie. Okay, so that's my graph. Okay. And then we're going to graph the other side. We want to know where y is going to equal 6. Maybe I have to put y equals here. Okay. So here I can see what where the graph is, and it even gives me an answer. Okay, it's equal to negative 5.873. And then positive 1.873. I'm going to zoom out for that. So right, this you couldn't do on your own, right? Because I'm not going to know, oh, it's negative 5.8373. Not going to guess that at all, right? And I'm not going to guess 1.873. Okay. That's why graphing isn't always the best way to solve this. So I'm going to see if I can snip this. Paste. Ooh. Well, let me do this. There we go. There we go. This is not helping at all. It's much easier. Okay, let's just undo all this. Okay, so you guys graph the best you can on this, seeing as though this does not want to work for me. Okay, but write down the answers for us, okay? So your answer should have been x equals negative, what was it?
-2, -9. Oh no, I'll look at the
5.873 and negative or a positive 1.873. Okay. So we can easily graph the 6, which isn't on our graph. I must have graphed a -6 or something. And we want it to cross here at -5 somewhere about, and here at 1 and something about. And then if we go back here, our vertex was at -2, -9. So -2, -9. So our parabola is kind of like this. Any questions over that? Now we're going to graph this one. We want to find where this parabola is going to equal 0. So we're going to go back to our Desmos. We're going to change this. To x squared minus 6x minus 5. And this time we want y equal to 0. Yes. So I'm going to show you a different way other than graphing. You may have to graph, but I won't give you ones that are going to be.
Can we just put it in the box and then on the vertex?
Find the vertex. It's not the vertex though, right?
Well, I mean,
If you want to, yes, you can rewrite it in vertex form
and then just rewrite it down.
and then graph it. Yeah, that's yes. If you don't want to use Desmos, you don't have to, or a graphing calculator. Okay, so this time our graph should cross right here. Okay, we're going to go back and identify the vertex so it's easy for us to graph this. The vertex is 3 and negative 14. So 1, 3, and negative 14 is like right here. And then so we cross at negative 0.742 and 6.742. So that's going to be like right here. Oh, I graphed on the wrong side, you guys. It's positive 3. I put it on negative 3. And then at 6 point something there. So x equals negative 0.742 and 6.742. Again, not fun and not easy to graph. So we will show you another way. So in example C, grab the packets. And you sit right here. What were the key features of that graph? What did the solutions end up being? What was the key feature that it ended up being? Any ideas? Last module, what key features did we learn about? Okay, let's call people. Isabel, what did we learn? No, okay. What some of our key features did we learn about last chapter? When we graphed, what do we need to find first? The vertex, okay? What's something else we found? Yep. The x-intercepts. What's something else, yeah? The y-intercepts, okay? So we found all those things. Okay, what are these in reference to those things? Our x-intercepts, okay? Example, what key feature of the graph do the solutions end up being? The x-intercepts. And that's what our solutions are going to be from now on. So now we're going to teach you how to solve this by factoring. So we don't have to graph it and estimate about 1.56 or whatever the answer could be. So the zero product property is if the product of two or more factors is zero, then one of the factors must be zero. Okay, intercept form of a quadratic is just factored form. Right, looks like this, f of x equals x minus 7 and x plus 3, something like that. Okay, when you are solving a quadratic, they're going to give you lots of different words to do the exact same thing. They're going to ask you to solve. Okay, so it could be a solution. They're going to ask you to find the x-intercepts. They're going to ask you to find the zeros. And they're going to ask you to find the roots. All of this means the exact same thing. It means solve this equation, solve the quadratic. But a lot of times you guys are going to get stuck because you're not going to be sure what it's asking you to do, because it has all of the different vocabulary words that you could possibly use to tell you to do the same exact thing, which is just solve. Okay. The solution to a quadratic equation is the x-intercepts. Make sense? Okay, so this whole chapter, we're going to be finding the x-intercepts, the zeros, the roots. So here's how we're going to do this. We're going to solve by factoring and use the zero product property. Okay, so the first thing we're going to do is put it in standard form. We want to make the equation equal to 0. So I want to find the x-intercepts, and when it's on the x-axis, the y values are 0. So I'm going to replace f of x with 0. I'm going to substitute in 0 for f of x. So I'm going to have 0 equals my x squared minus 10x minus 24. Then we're going to factor. So I use the box. Okay, Sarah, what multiplies the x squared? Oh, x and x, and then you said 6 and 4? Okay, what multiplies to 24 is 6 and 4. So then I find the area of this box. It's 6 times x, which is 6x. The area of this box is x and 4, which is 4x. Remember, this is telling me, oopsie, to subtract. If I subtract 6 and 4, do I get 10? No.
Negative 12.
Okay, let's try that. So that didn't work. We're going to erase that. Make sure you're always checking your work, because it's not going to be necessarily the first time you get it. So 12 and 2. 12 times 2 is 24. Find the area here. This is 12x. This is 2x. Now if I subtract those two, do I get the negative 10? Okay, so the 12 needs to be negative. and the 2 needs to be positive. Okay, the 10 is negative because, the 12 is negative because the 10 is negative, and you need the bigger number to match. So this is a negative 12, this is a positive 2. So my factors are going to be x minus 12 times x plus 2, and we want it to equal 0. So I just substituted my x squared minus 10x minus 24. I factored it and just rewrote it in factored form.
Oh, wouldn't you have to change the 12 positive and then make the 2 negative?
No, that's if I gave you just the x-intercepts and you wanted to write it in the equation. Since I'm factoring it here, it's already going to keep the sign. Okay, so we're going to write it in factored form. Then we're going to use the zero product property by setting each factor equal to 0. So if my equation equals 0, one or both of these factors has to be 0. Okay, so to figure out what that would be, I'd have x minus 12. What would x need to be to get 0? And then x plus 2. What would x need to be to make that factor 0? So here we'd add 12 to both sides. Please show all the work in the notes so you remember what happened. And we get x equals 12. Here, we're going to subtract 2 from both sides. Then we get x equals negative 2. So my x-intercepts here, or my solutions, or my roots, our x could be 12 and negative 2. Any questions over that? Okay, next one. Okay, this one, we need to find the solutions. We're going to do the same steps. Okay, but there's not an f of x to substitute in a 0 for. So we just need to set this equation equal to 0. Okay, in order to do that, that's our first thing. I'm going to set it equal to 0. We want to get rid of this 12. How do I make 12 0? Subtract 12. So I'm going to subtract 12 from both sides. I still have the 3x squared. I still have the negative 16x. But now I have to put the negative 12. None of those are like terms, so I'm not going to combine any of them. And now I have it equal to 12 minus 12 is 0. Any questions over that? Now that it's equal to 0, I can factor it. Does this have a GCF? Can they all be divided by something?
No.
No. In this case, no. So you guys do want to check to see if there's a GCF. It'll make it easier for you guys to factor and solve it. So 3x squared minus 16x, and then minus 12. Okay, you all factor that. Okay, Kate, what did you guys get? The factors. Mm-hmm. X minus 6 and 3x plus 2? Awesome. Do you guys agree with that? Okay, let's check this. Okay, so this area would have been 18x. And we said that was negative, so that would be negative 18. And this would have been just 2x. Okay, if I subtract them because it's negative, I would get negative 16, so we did good. Okay, now it's equal to 0. So the next step is to split up your factors. One of these factors has to be 0, one or both. So we're going to see what x needs to be to make those 0. So this is easy. I just add that 6 to both sides. and I get x equals 6. The next one, I'm going to subtract the 2. We get 3x equals negative 2. Not done yet, though, because I have 3x. Yep. Divide by 3 on both sides. And I get x equals negative 2/3. So my solutions are x equals 6 and negative 2/3. Any questions over that? Okay, next one. Okay, I'm gonna have you guys do this in your pairs. Solve it, factor it, and solve it. So we had our 2x, our 2x squared, 13x and 15. We have 2x and 3 and x and 5. This is 3x, this is 10x. Everything's positive, so we're adding everything. So everything is a plus. So our factors are x plus 5, and then 2x plus 3 equaling 0. So we have x plus 5 equals 0, and then 2x plus 3 equaling 0. So that gives me x equals negative 5. Subtract the 3. 2x equals negative 3. Divided by 2, divided by 2. And negative 3/2. I think everyone got there. Good job. See, pretty easy, right? Okay, this one is a little different because I do have a GCF. Yes. Not just 3. 3x. So I have my 3x squared and then negative 6x. So I can factor out the 3x and get left with x minus 2. Negative 6 divided by 3 is a negative 2, and the x's will cancel. 3 divided by 3 is 1, and then I take away an x. So now I'm at 3x times x minus 2. Now, since this x minus 2 doesn't have a squared variable, I don't need this box. Only if there's a squared variable do I try to factor it more. Does that make sense? No squared variable, I'm done. So just like before, I'm going to separate my two factors and set them equal to 0. So 3x equals 0. And then x minus 2 equals 0. Here I divide by 3, divide by 3. What's 0 divided by 3, class? 0. Right? 3 can't go into 0. It goes in 0 times. Here I add the 2. Oopsie. And I get x equals 2. So I have x equals 0 and 2. Any questions? Okay, please answer those two questions. When we solve quadratic equations, why do we set it equal to 0? And then summarize what we've learned. Why do we set it equal to 0? Everyone's writing something, please.